In heat and thermodynamics, next we will take the isobaric process. Isobaric process is the process in which pressure remains constant. And as per the ideal gas equation, that is PV equal to nRT, if pressure is constant, n number of moles and universal gas constant R is also constant, therefore we can write V is proportional to T. Therefore, for isobaric process which have pressure constant, we can write V is proportional to the absolute temperature. Here in the diagram, we have shown the PV diagram for the isobaric process, and here the two processes. One is the compression. In compression, volume reduces, while in expansion, volume increases. Here, final volume in expansion is greater than the initial volume, while in compression, final volume is less than the initial volume. Therefore, work done in the isobaric process, or in general for expansion, work is greater than 0, that is, it is positive, and in compression where volume reduces, we can say work done is negative. Therefore, we can write using the work definition, it is integral P dV, and because pressure is constant, it is taken out of the integral, so it remains dV, and we integrate from initial to final. Therefore, work will be P into V final minus V initial, or we can write it is P into delta V. Here we have written work done is P into delta V, and using the equation of the ideal gas, we can write P delta V equal to nR delta T, because in ideal gas equation PV equal to nRT, and here we change the volume, so P into delta V, because P remains constant for isobaric process. So because of this volume change, there is a change in the temperature. So we can write P delta V equal to nR delta T. Using the first law of thermodynamics, which is the dQ equal to du plus dW, that is heat exchange equal to the change into the internal energy plus the work done. And we know in terms of the molar specific heat at constant pressure and volume, this dQ is ncp dt, where Cp is the molar specific heat at constant pressure, and it will be equal to ncv dt, where Cv is the molar specific heat at constant volume, and it will be equal to the du plus P dV. Because P is constant in isobaric process, so this P is taken out from the definition of work, and it remains P into dV. Therefore, P dV, we have already written that it is equal to nR dt. So this P dV is replaced by nR dt. So the definition for the first law of thermodynamics gives ncp dt equal to ncv dt plus nR dt. In isobaric expansion, as we have mentioned, because the volume increases, hence work will be positive, and for expansion, heat will be given because pressure remains constant, hence this du, that is the internal change in internal energy. For isobaric expansion, this given heat, for isobaric expansion, the heat change will be greater than 0, that is positive, work done will be positive, and the internal energy change is also positive. Work will be positive because this is expansion process in which volume increases, and dq will be positive because heat is given to the system which is required to give the expansion, keeping the pressure constant, and in this process temperature of the gas increases as heat given is also increases the temperature of the gas. In the similar way, we can write isobaric compression has the change in heat, internal energy, and work done are all negative. This dP equal to 0 refers the isobaric process, but delta P equal to 0 does not necessarily specify the isobaric process. Let's take one of the problem. In a cylinder, 2 moles of an ideal monoatomic gas, initially at 1.0 into 10 power 6 Pascal pressure and 300 Kelvin temperature, expand until its volume doubles. Compute the work done if the expansion is the isobaric process. For isobaric process, we know P is constant, so work will be equal to integral P dV from initial volume to final volume. Because pressure is constant, so can be taken out, and it is integral dV from initial to final volume. An integral of dV is V and limits are Vi and Vf. So we can write it is P V final minus V initial. So this is the work done by the gas. Here for ideal gas we know PV equal to nRT. Therefore we can replace this P by nRT by V. Therefore work will be equal to nRT by V into delta V. Here the number of moles of the gas are 2 moles, so it is written 2 into R is the universal gas constant, it is 8.3 into temperature is 300 in Kelvin, and initially the temperature is this volume is V, and then final volume minus initial volume, because finally volume is 2V minus V. Therefore this get cancelled by V and it remains 2 into 8.3 into 300, and on solving we will get 830 into 6, or it is 4980 joule. So 4980 joule will be the work done in this isobaric expansion.